Alright, I'm going to go ahead and talk to you about section 3B in 3 parts. In this video, I'll talk to you about this first half here, 3.8 through 3.11, and then I will do 2 videos about significant digits, one with the concepts and then one with some practice. Okay, as I talk, I'm going to ask you a couple of questions, and I want you to write those questions down, okay? And then I want you to write down the answers with them. That's sort of what shows me that you watched the video, okay? As we talk, I've got this whiteboard here. I'll try and put that in the picture and try and explain some things further and write as I talk. All right, so what we find is, as we are scientists and trying to approach problems scientifically, we find that we need to make measurements, but we also find that our measurements are never perfect. So there's always some limitation in measuring. So my first question for you is, what are some ways we are limited in making measurements? Okay, that's my first question that I want you to write down. What are some ways that we are limited in making measurements? And I don't believe your book specifically goes over these 4 things, but these are the answers, okay? The first way we're limited is that our instrument's markings are not perfect. So the little line spacings, it's made by a machine, but that doesn't mean the machine is perfect. Okay, that's always possibly not exactly right. Another way our measurements are limited is because people can easily read the instrument incorrectly. Okay, so if we read the instrument incorrectly, we end up with some problems. Okay, that's another limitation. A third limitation is our instruments may be damaged or have defects. We might not even realize it until it's too late. So that's another issue. And then the last one is the environmental conditions might interfere with our measurement. And when we say that, now this is an extreme environmental condition, a hurricane, right? But think about it, if you're trying to, maybe make a measurement of a bird in the Amazon, okay, you're going to be limited in the way that you're able to do that. Or if you're at the top of the tree trying to gather a sample or do something like that. So all of these are ways that we are limited. So that's the first question. How are we limited in making measurements? And the answer is those 4 things. Feel free to pause the video or check out the Prezi here to get those answers. All of that leads to something we call error. Okay, error is the difference between our measurement and what we think it should be. Okay, error is the difference between our measurement. Okay, the difference. My messy handwriting here. It's the difference between our measurement and a standard. Okay, what we think something should be or what we think it really is. Okay, the difference between our measurement and some standard. So that leads us into talking about these 2 terms, accuracy and precision. Okay, accuracy and precision. All right, so first let's talk about accuracy. Accuracy is a measurement of error. Accuracy is a measurement of error. When we find accuracy, we are comparing to a standard. Okay, there's 2 types of error we might calculate: absolute error and percent error. Okay, absolute error and percent error. Okay, so accuracy tells us how much error do we have. Okay, in order to calculate this, we have to know what that standard is. Okay, so let's look at an example. Okay, suppose we have a boat. Let's say it's a boat that's as big as the Titanic, very big boat. And we know that this boat, according to the designers, the boat is 1,000 meters long. Okay, but we go out there with our ruler and we measure it, and we measure it to be 1,010 meters long. Okay. When we want to calculate absolute error, we're going to take our observed value and subtract the standard value or the accepted value. Okay, so observed minus accepted, that is the equation for absolute error. So in this case, it's 1,010 meters minus the 1,000 meters, which gives us 10 meters. Okay, so 10 meters off, which, you know, what does that mean? Well, we're 10 meters off. What does that really mean? Well, in order for that really to make sense, we want to use the percent error calculation. So the percent error calculation takes the absolute error and divides it by the accepted value, and then turns it into a percent, 100%, which I put absolute signs there. Really, you don't need them because absolute error has absolute value signs in it. So we do this division and then multiply by 100%. That's percent error. So for this situation, we would get our absolute error, our 10 meters, and divide it by our accepted value, our 1,000 meters, multiply by 100. Okay, that's going to be 1 over 100 times 100%. Okay, I can use my calculator for that. I would recommend you can pull out your calculator if you want. That gives us 1% error. 1% error. Okay, for most applications, what's a reasonable amount of error is less than 5%. So that actually doesn't look too bad. Only 1% error. We're pretty close to the correct length. And this is a big boat, right? Like it's hard to measure a big boat like this. Okay, let's consider another situation. Okay, where I've got another boat, except now it's just a little old sailboat. Okay. Same situation. I know that according to the boat's plans, okay, it should be 30 meters long. But when I measure it to be 20 meters long. Okay, so once again, we'll look at our observed minus accepted value. So my observed value is 20 meters. The accepted value is 30 meters. I take the absolute value of that, so it's positive, and I get, voila, once again, 10 meters. Same exact absolute error as I saw before. And so now let's go over here and find the percent error. So now I'm going to take my 10 meters, divide it by the 30 meters, that's the accepted value, multiply by 100%. Okay, 1 over 3 is what this part reduces to, so 1/3 times 100% gives me 33.33333 repeating percent. 33%. Yikes! Okay, 33% error is a lot of error. That is not okay. Alright, so up here when I was 10 meters off on the big boat, it wasn't a big deal. Now when I'm measuring the sailboat, it is a big deal. Okay, so I'm going to ask you to think a lot about what is acceptable for a given situation. Okay, the bigger something is that you're measuring is, the more room there is to be wrong. Okay. All right. So my second question for you that I want you to write down and answer is, what is the difference between absolute error and percent error? Okay, what is the difference between absolute error and percent error? I want you to write down that question and then answer it using this information we just talked about. All right. The second topic we'll talk about here when it comes to error and uncertainty, we now want to talk about precision. Okay. Precision tells us how sure are we? How sure are we about a measurement? Okay, it tells us about the uncertainty we have, and it's going to depend on the instrument that we are given. If I have a meter stick, Okay, and then I want to go and I want to measure a book, the length of a book with a meter stick, and all I know is that this end is 0 meters and this end is 1 meter. I'm sort of stuck just sort of estimating, right? It's definitely less than half a meter. I'm going to say that maybe it's about 0.2 meters. You might have said, no, it looks like 0.3 meters to me. I don't know. Somewhere in there is going to be okay, but neither of us really knows because there's no markings. Okay, now if I were to use 7, 8, 9, 10, okay. If I were to use a meter stick that has markings every 10th of a meter, which would be a decimeter, okay. Now I can make a little bit more of a precise measurement, and now I see, yes, it definitely is 0.2, and it's actually a little bit past 0.2. Once again, I can make an estimation. This looks like now it's about 0.2. I'm going to estimate 2, and it's still meters, so 0.22 meters. So this over here only has 1 digit after the decimal. Here we have 2. Because we have a different instrument, okay? So again, it depends on our instrument. And then as we take our measurements and we do calculations with them, we want to maintain our precision. And we'll talk more about this in 3C. We'll talk more about how we do calculations. But the basic idea is when we do calculations, we can't let our calculator think for us. Okay, so if we have this quartz and we want to find its density, here we're given a mass and a volume. Okay, when I put this into my calculator spits out a really long number. Okay, so 27.55 grams divided by 10.4 centimeters cubed. That is 2.64903846 grams per centimeter cubed. That is way too many digits, and we'll talk in 3C about how to choose how many digits to keep. Another important thing to know about precision are there are a couple spots where precision is infinite, and that's anytime we have a defined quantity. For example, 100 centimeters equals 1 meter. That's infinitely precise because it's defined. 100 equals 1, just like that. And then the other case is when we have numbers and counting. So if we just count the number of people in the room, that's infinitely precise because I can't have part of a person. Okay, the only time precision comes into play is when we have an instrument. All right, there's this rule of thumb. When measuring with a metric instrument, we report the measurement to 1/10, sorry, that's a typo, 1/10 of the smallest decimal subdivision on the instrument scale. And if you take a look at page 57 in your book, you'll see some typical precision of lab instruments we'll go over. All right, so my third question for you to write down here is, what is the difference between accuracy and precision? Okay, what is the difference between accuracy and precision? And this sort of illustrates it, okay? Accuracy, when accuracy is high, we are relatively close to the correct value. Okay, when accuracy is high, we are relatively close to the correct value. You'll notice that all of these are very close. The correct value is the center, of course. Here, all of these are very close to the center. And over here, they're not all close to the center, but they're pretty evenly distributed around the center. Okay, so that even distribution, okay, the average of them is the center. Okay, and then precision tells us how close our measurements are together. So with high precision in both of these cases, they're all very close together. But down here, they're not actually close to the target because they're low accuracy. Okay, so over here where we have low accuracy and low precision, they're spread out and they're not averaging close to the center. Here, high precision but low accuracy, they're all close together but not close to the center. All right, the last thing we'll look at here is solving problems. We know that immunotherapy is a treatment that we can use for allergies, and it requires that we measure out carefully and provide a dose to patients. So this is definitely a place where you would need to be precise and accurate to a good degree so that you don't hurt anyone. All right, and that's where we will pause for this part, and I'll follow up with the next video. Make sure you write down those 3 questions we discussed and have those ready to turn in.